Alright guys, this is chapter 18 and 19 quiz. Number 3. According to Gallup, about 33% of Americans polled say they frequently experience stress in their everyday lives. The question states, if you're in a class of 45 students, what's the probability that no more than 12 students in the class will say they frequently experience stress in their daily lives? And then we'll get to this stuff here in a second. So first and foremost, what we need to recognize about this problem, or the first question we need to ask about this problem is, are we talking about means or proportions? And so in this particular case, they're talking about a percentage of Americans polled say they frequently experience stress in their everyday lives. Number one, these are Bernoulli trials, and they're Bernoulli trials because we have success fail. Success would be that they frequently experience stress in their everyday lives, and failure in this particular case would be that they don't experience stress. They don't frequently experience stress in their everyday lives. So we should recognize this hopefully as Bernoulli trials, and down here we've got a set number of trials that we're going to run in our particular question. So this is going to be a binomial distribution. That's the first thing to recognize. We're dealing with proportions, and it's a binomial distribution. Once you see binomial, you should say, hey, hopefully I can use the normal distribution to approximate the binomial, and then we can go forward with the calculations based on this being normally distributed. In order to do that, we need to check a few things. So this is where the conditions come into play. Check all necessary conditions, and then we'll get to the sampling distribution and those things next. So what we want to do is we want to check the conditions necessary to estimate the binomial distribution with the normal distribution. And here are those conditions. Number one, is it a random sample? So the sample that we took, 45 students, are they randomly selected? Number two, is each student independent of another? So does the probability of one student saying they frequently experience stress in their everyday lives, does that affect the probability of the next student saying that they frequently experience stress in their lives? We'll get to these in a second. Next one is our sample less than 10% of the population? And number four, the fourth condition is, can we expect more than or equal to, so greater than or equal to 10 successes and failures? So can we expect at least 10 people to say they frequently experience stress in their everyday lives, and can we expect at least 10 people to say that they don't frequently experience stress in their everyday lives? So let's go through these one by one quickly. Number one, is it a random sample? Well, in our problem, it doesn't say anything up here about this being a random sample. So not necessarily mentioned within the problem, so we need to proceed with caution. It's not necessarily random. It could be, or it could not be. We don't know. Hopefully it is. We'll proceed with the procedure with caution. Number two, is one student selected independent of another, or is the probability of one student saying they frequently experience stress, does that affect the probability that the next student says they frequently experience stress? What I said was not necessarily all students are in the same class together, and what I mean by that is certain classes are tougher than other classes. So we need, again, to proceed with caution in this particular case. We don't know whether they're independent or not. So we'll check the last two. Obviously those two don't check out. We'll go ahead with the calculations and just kind of note that, hey, these two things aren't necessarily satisfied. Next one, is our sample less than 10% of the population? Well, it will be if we have at least 450 students for this to be the case. All right, so we have 45 students in this particular case, and actually if you go back up to the original problem, it's talking about all Americans. So these are American students that we're talking about, so this is a much smaller subset of the population. So depending on what you are studying, if you're studying or if you're trying to make a conclusion about the students in this particular school or students in general, then we need to have this caveat. If it's students in general, then this would definitely be satisfied. If it's students in this school, then we'd need to have at least 450 students in the school for this to be the case. because our particular sample has 45 in it. So we're going to go ahead and assume that this is satisfied if this particular study is talking about all students, or more generally all Americans, and we're just polling students. Last one is, can we expect greater than or equal to or more than at least, let me rephrase that, at least 10 successes and failures. And in this particular case, the population proportion is 33%. We took a sample of 45, so I would expect 15 quote-unquote successes, or 15 people to say that they frequently experience stress in their everyday lives, and I would expect 30 to say that they don't. So this particular condition is satisfied. So the next step, we've checked all the conditions. We've noted that maybe these two aren't necessarily satisfied. We're going to go ahead and proceed with caution with the calculations and the rest of what we need in order to calculate this or answer this question. So the next step is to build your model. And this is a sampling distribution. We know the population proportion is 33%. So we know the population parameters. We know P, and we can calculate the standard deviation of this particular thing. So we know these population parameters, but what we've done is taken a sample. So our model is going to take that sample into account. Remember, smaller samples are going to lead to more conservative estimates. So we need to make sure that we take this into account, that we only have 45 students. So our model, we know that it's going to be determined by the mean or the middle, and we know that the mean of the samples is going to be centered around the population proportion. So our model that we're going to use or operate under the assumption that's true here is that the population proportion is true. The standard deviation of the p-hats is going to be dependent upon what our p-hat is. Alright, so we calculate the standard deviation by taking the square root of P, the population proportion because we know it, times Q, over whatever our sample size is. And so we're going to plug in our values here. Our standard deviation of this sampling distribution is going to be 0.33 times 0.67 over however big our sample is, and our sample in this particular case is 45 students. So plug that into your calculator, and what you come out with is rounded, we've got a standard deviation of 0.07. So our model that we're going to operate under or do this calculation under is going to be the normal model. We've checked the conditions. They don't necessarily all check out. We're going to proceed with caution, but it's going to be the normal model centered at the population proportion with a standard deviation of 0.07, which again is based on how big our sample is. Quick sketch of what our model might look like. We're approximating this binomial distribution with the normal model. So at the center of that is going to be 0.33, and it's going to have a standard deviation of about 0.07. So let's go back up. We can now calculate. We want to know what the probability that no more than 12 students in the class will say that they frequently experience stress. So no more than 12, what we're really calculating is the probability. What's the probability that our particular p-hat is less than or equal to 12? Well, in order to do that, we need this. Our p-hat is going to be 12 over 45. So go and plug that into your calculator. Then we get 0.267. So we want to know what the probability of getting a p-hat, or taking a sample and getting a proportion that is no bigger than 0.267. Alright, come back up here and we'll label our diagram here. It's going to be somewhere over to the left. We don't have to be super accurate with this. We just want to get an idea. And we want to know this particular probability. What's the probability that if we go take a sample, our p-hat is going to fall in that region? So the last phase of this is to go calculate that probability. What is the probability that our particular sampling distribution, or our particular sample, has a sample proportion that's less than 0.267 if we're operating under the assumption that the population proportion is still true with a standard deviation of 0.07. So because we're using the normal model to estimate this, what we can do is we can use those nice little functions here. What we're looking for is we want to find the area under the curve. So we want to do normal CDF our left endpoint is going to actually be 0 because we can't get a proportion that's less than 0. Our right endpoint is we want to calculate up to our particular p-hat, and that'll give us the area that we shaded up here, so that would be 0.267. And next we need to enter our parameters for our normal model that we're operating under, so that would be a mean of 0.33 and a standard deviation of 0.7. Alright, we plug that into our calculator. We come out with a number, a value that looks like this. So what does this value mean? Well, what this means is if we're operating under these population parameters and we have a sample of 45 students, we know that the normal model is going to look like this. What this in particular means is that 18.4% of the time, if we draw a sample of 45, we're going to get a sample proportion that is at or less than 0.267. Alright, so let me type that out just so we can make this clear. Again, this is specific to a sample of 45. So if we draw a sample of 45, there is an 18.4% chance that our sample proportion, or p-hat, is 26.7% or less. And again, in context, this means that with a sample of 45, of size 45, 18.4% of the time our sample proportion that we return will get 26.7% or less that say they frequently experience stress in their everyday lives.